Welcome. Today we're doing number of provinces. There are n cities. Some of them are connected while some of them are not. If the city A is connected directly with city B and city B is connected directly with city C, then city A is connected indirectly with city C. A province is a group of directly or indirectly connected cities and no other cities inside of the group. You are given an n by n matrix is connected, where is connected ij equals 1 if the ith city and the jth city are directly connected, and is connected ij is 0 otherwise. Return the total number of provinces. Okay, so n by n means we're going to have the same width and length. That's accurate there. We can have up to 200 points, up to 200 cities, which means 4,000 points. Is connected as Boolean, is connected I equals 1, and ij equals ji. Okay, so our constraints are going to start off with width equals length and ij equals ji. And I equals 1. A city's always connected to itself. So if we take this example, we've got an array. Well, we've got 3 arrays inside an array. Which means 0, 1, 2, or no, it's 1, 1, 0, 1, 1, 0, and 0, 0, 1. And then let's change that to code. Okay, so our constraints mean that the top is going to be equal to the bottom. So I don't need that stuff, and this is always going to be ones. So I'm really worried about right here. So in this case, I should be able to find one city that's connected to another city, and then one city that's connected to no one. So if I create an array of root cities, every city is its own root because they're all connected. That makes sense. So if I go 0, 1, 2, And then I check, let's see, this will be, I think it'll be more, crap. Dang it. 0, 1, 1, 1, 0, 1, 1, 0, 0, 0, 1. Okay, I think it makes more sense to look at this half. So we can cross out these guys, and then we can call this guy complete. Okay, then I need an array of roots. Let's move that over there. 0, 1, 2. Every array is its own root, or every node is its own root. So if I start with row 0, column 1, I find that's true. That's a connected city. So I want to make sure that for every make sure that for every root 1 it points at 0. So I'll go through here, kill that, and then I check here, that's nothing, so I don't have to worry about it. I check here, that's nothing, I don't have to worry about it. And then I'm done. So then I have 2 nodes with a root of 0 and 1 with a root of 2, and I want to return the individual numbers. So at that point we can just set them. Okay, so to make this work, first I need to make this array. So let's go R equals, we'll construct it with a range. So I, for I in range range length is connected. Okay, so it's an n by n matrix. I need an array that's the length of n. So for the length of is connected, I get a range, and each point along n represents a city. So I just use the index name for the city. Got it. Okay, then we only want to traverse the top triangle. So we'll start with for I in range length is connected. And then, so if we start at 0, we want to start at 0 plus 1. For j in range length, range I plus 1 length is connected. Okay. Now I'm checking, is this a connected city? If is connected, ij. If it's 1, then it is connected. If it's 0, it's false. Then I want to perform, I want to replace all of the roots with I, all of the j roots with I. So let's go for x in range length r. If r x if array of x is not equal to so I want to replace all the j's with i's. So if array of x is equal to j, then array of x equals I. Okay, that's super deep. We can probably do better than that, but for now we'll call it good. Let's return the length of the set of R. Accepted. Okay, let's do a quick refactor so we don't have 6 tabs deep. Let's just put in a function and call it def union. And it'll take x as an integer, y as an integer, and return none. And then we can take these three we'll do union I, j. Okay, and this is, we'll call that root. For root in the length of R, if root equal to I, oops, if root equal to Y, then root equals X. Test that. Still good. And we'll submit. it failed this one. Expected 1, found 4, and found 2. So over here we have one, 0, 0, 1, 0, 1, 1, 0, 0, 1, 1, 1, 0, 1, 1. And then okay, so we have zeros connected to 3. 0 to 3, 1 to 2, 2 to 1, and 2 to 3, and 3 to 0, and 2. Yeah. Another way to look at this is, let's see, 2 is the hub. 1 is connected to 2, and 3 is connected to 0. So connection, connection, connection. Yeah. Okay, so I gotta figure out why this is failing. I'll use this test case. And where do I want to print this out? Let's go with print ij r. Right. Okay, so with 0 and 3, I expect 3 to become 0. Then at 1 and 2, one, 2, if 1 and 2 is connected, then I want all 2's to become 1's. Let's check. And then 2 and 3 is connected. need to print R after the union. Okay, if 2 and 3 is connected, then I expect all 3's to become 2's. You know what? I'm looking for 3's, not 0's. I expect all 0's to become 1's in this case. So I need to translate the x's into root of x's equals Rx, and then root of y equals R of y. Okay. And that worked. Awesome. Submit. Boom. Beats 9%. That is so bad. Wow. Okay. Well, it's a success. Thank you for joining me.